Hi class, let's take a look at example 2. And the first step on example 2 is to identify what they're asking. So we're looking at a 95% confidence for the actual variance. So this will be sigma squared. And they want us to provide a sketch for the critical values. So let me just create the sketch. So in this case, the critical values are going to be as follows. Now we're using 40, so the degrees of freedom, it's technically n minus 1, so we're talking about 39. So on this particular one, let me provide a basic sketch. Now your sketches don't have to be accurate in terms of what the distribution looks like, but for this particular one, because the degree of freedom it's large, our actual curve here is going to look approximately bell-shaped, but it doesn't have to be to scale. Let me just clarify this with actual decimals. So remember that we did one of the labs, and here's the basic idea. So that's a degree of freedom of 8. Ours has 39, so as your degrees of freedom increase, your actual sketch, in this case, that's your actual chi-square distribution, looks approximately bell-shaped. However, if you were to draw it, well, not with 0, but if you were to draw it with the typical one, this is like the most typical one that you're gonna see on all the textbooks. Something like this, that would be perfectly fine. It doesn't have to be to scale. So let me go back to this one. And we're still gonna have the same placement. So we're gonna have that this portion here, it's the one on the left. This chi-square value here, it's gonna be the one on the right. And then let me actually shade it. So this is going to be C, which is equal to 0.95. If C is equal to 0.95, that means that alpha is equal to 0.05. Alpha divided by 2 is 0.025. So therefore, you're going to have in this tail 0.025 and in this tail 0.025. So that means that the total cumulative area for the one on the right, it's going to be 0.025. And the one on the left, it's going to have the 0.95 plus the 0.025, which is going to give us a total of 0.975. So these are the areas that we're going to be looking at the table with a degree of freedom of technically 39. And this particular one, it's going to have a minor problem if we're looking at the table, but for the exam it's going to be fine. So let me pull out the table. So remember that we're using the chi-square distribution, and then your degrees of freedom, because n is equal to 40, would be 39. So I'm looking at this portion here, 40, 39 degrees of freedom. The problem with that degree of freedom is that it's not on the table. You're either using 30 or 40, or the closest one of those two to 39. So we would be using 40. That's the closest one to it. And then the total area for the one on the right, it's going to be, or actually it's 0.025. So the actual critical value would be 59.342. So this one, 59.342. So 342, then 975. So 24.433. So 24.433 2433. And let me just rewrite it that the critical values using n is equal to 40 are the one on the left, which is 24.433, and the one on the right, which is approximately 59.342. Now, let me pause the video before we go to the next portion, which is going to be to evaluate the formula. And then I'll let you to catch up. The main idea on this one is that, well, because of the n is equal to 40, if we're using the table, we would carry a little bit of error. If you had this problem on the actual homework assignment, it would be asking for you guys to use technology. So let me pause it for a minute for you guys to catch up. Hi class, let's go to the last portion of the problem. And what we're going to do here is now we're going to be applying the proper formula. Since they only want the variance, I'm just going to go directly to the formula and then evaluate it on the calculator. So no need for the standard deviation. They're not asking for the standard deviation. So in this case, the 95% CI for sigma squared, it's technically given by the following formula. So our sigma squared, so we're looking at sigma squared, it's technically bounded by the values of n minus 1 times s squared. And then we have the 1 on the left on the right, and then n minus 1 times s squared with the 1 on the right. Now, the reason that you have these in this format, and I'm referring to the actual critical values, is so that the actual calculations provide us the interval from min to max. So having the larger one on the left, in this case this one, it's going to give us a smaller ratio, as having a smaller value on the right would give us min to max. And then also we're going to be using the values of n is equal to 40. We still use n minus 1 on the formula, and then s is 140. So s is equal to 140 given in the problem. So we're going to be evaluating on the calculator the following. This will be 39 times 140 squared over the 24.433, and then 39 times the 140 squared over the 59.342, which is actually going to give us that the variance it's bounded by the following two values. On the upper bound, I have that this is going to be so on the upper bound, I'm getting 31 28.5.56. I'm just rounding to 2 decimal places, and then 12,881.26. And let me just double check the calculation. 59.342 24. Let me just rewrite it as the 95% CI for sigma squared is, and in this case 12,881.26 to 31,285.56. 56. The units happen to be, actually, I don't see any units. I don't see units given in here. So I'm just gonna write it with units since they're not providing, but I'm pretty sure the problem actually has units. So if it doesn't have units, you basically still rewrite it with units. Let me double check. Yeah, I don't see it. I just see those numbers, but nothing else given. That's actually it for this specific problem.